Let's use integrate by parts to try to evaluate an expression. If we begin by using liate without thinking, we would choose u to be sine of 2x, and dv to be e to the sine of x dx. That gives us 2 cosine of 2x dx for du, but then we get stuck when we try to integrate to find v. We don't have a way to integrate e to the sine of x. So let's try switching our expressions for u and dv. We set u equal to e to the sine of x, and set dv equal to the sine of 2x dx. We then get du is equal to cosine of x times e to the sine of x dx. Integrating dv, we get v is equal to negative 1/2 cosine of 2x. Substituting these into the integrating by parts formula, we get negative 1/2 cosine of 2x times e to the sine of x minus the integral of negative 1/2 cosine of 2x times cosine of x times e to the sine of x dx. It looks like using this substitution has actually made our integration more difficult, so let's try another approach. Notice that we can rewrite sine of 2x using the double angle formula. So our integrand becomes 2 sine of x cosine of x times e to the sine of x. Next, we let u equal sine of x and set dv equal to cosine of x times e to the sine of x dx. So we get du is equal to cosine of x dx, and v is equal to e to the sine of x. Now let's try to substitute into the formula for integration by parts. We need to make sure to include the coefficient of our two calculations. So we get 2 sine of x times e to the sine of x minus 2 times the integral of cosine of x times e to the sine of x dx. Notice that we can integrate this integral with a simple u substitution. So we get 2 sine of x times e to the sine of x minus 2e to the sine of x plus c. Therefore, our original integral is equal to 2 sine of x times e to the sine of x minus 2e to the sine of x plus c.